Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about impulse invariance method of designing an IR filter. So the given problem is design a third order Butterworth filter using an impulse invariant technique. Assume that sampling period t is equal to 1 seconds. So from that we know that n equal to 3. So we can directly write the normalized Butterworth filter is h of z equal to 1 divided by s plus 1 into s square plus s plus 1. So from this we can apply partial fraction. So first one we have only s plus 1. So we can write it a divided by s plus 1. Here we have s square plus s plus 1. Whenever multiplying it we need to get a 1. Whenever we are adding also we need to get it 1. So real number is not possible, we get a complex number only. So use a calculator and select the degree and unknowns, that will be 2. You can apply this value 1, 1, 1, you get these answers. So this is a complex conjugate of two values, we can directly write it. So we can write it BC or B star, both will be same only. So B divided by S plus 0.5 plus J 0.866 plus C divided by S plus 0.5 minus J 0.86. These two will be complex conjugate manners. So any one is needed to find it, and another one we can directly write it from the complex conjugate of that number. So we need to find A, again we need to find B or C, that is enough for us. Now I am going to find it A, so I am going to find a A, so substitute with S equal to minus 1 and that function cancel, no? So for that we need to substitute S plus 1, multiplying it. So because if we multiply with the S plus 1, this S plus 1 will be cancelled. So only remaining time we can substitute it, because if you substitute S equal to minus 1 in this expression, minus 1 plus 1 becomes 0. So 1 by 0 becomes infinity. That's why that function should be removed. That's why we are multiplying with S plus 1. So s plus 1 will be cancelled, remaining only we have 1 divided by s square plus s plus 1, where s should be replaced by minus 1. So minus 1 square plus minus 1 plus 1. So minus 1 plus 1 will be cancelled, we get minus 1 square, that is 1. So 1 divided by 1 equal to 1. So A equal to 1, we are getting a final answer. Now we can find a B or C. So one will be sufficient, another one will be complex conjugate. I am going to find a B. So B expression is s plus 0.5 minus j 0.866. So that function will be cancelled. Remaining only we have 1 divided by s plus 1 into s plus 0.5 minus j 0.866. So this function will be cancelled both. Now substitute s equal to minus 0.5 minus j 0.866. So once you substitute it, instead of s I need to substitute this value. So both here and here. So once I substitute it, I get this expression. Now I am going to simplify this. So simplifying this, we get the value of 1 divided by minus j 0.1732 into minus 0.5 minus j 0.866. That will be equal to 1 divided by minus j 0.86 minus 1.5. So now we can simplify this. So that becomes minus 0.5 plus j 0.288. So C will be simply find by a complex conjugate of this number. So that will be equal to minus 0.5 minus j 0.288. So we have find out A, B, C value, just substitute it. H of s equal to 1 divided by s plus 1 plus 0.5 plus 0.8282j divided by 1 plus, that is s plus 0.5 into j 0.86. Same thing for this also. Instead of plus, you need to put a minus, that is complex conjugate. So minus 0.5 minus j 0.288 divided by s plus 0.5 minus j 0.866. Now we can simplify this. So just we can rewrite this expression in terms of single pole filters. So we need to have an, instead of s plus 1, we should have an s minus of something. So that's why I am rewriting this 1 divided by s minus of minus 1. So minus of minus will be plus, so you get the s plus 1. So I am get 8s minus of minus 1. So this minus 1 will be a coefficient here. Similarly for this also we have plus. So instead of that we need to take a common minus. So that's why I am taking this numerator value minus 0.5 plus 0.282j divided by s minus 0.5 minus j 0.2866. So if you multiply this minus inside, you get the same expression. Similarly here also I am inserting a minus here. So numerator keep it the same value, s minus of minus 0.5 plus j 0.866. Now we can use the formula. We know that h of s equal to k is equal to 1 to n ck divided by s minus pk. So that will be mapped as h of z equal to k is equal to 1 to n ck divided by 1 minus e power pkt into z power minus 1. So directly take the values and substitute it. So you get h of z equal to 1 divided by 1 minus e power, here value will be only minus 1. So e power minus 1 into z power minus 1, this is for first term. Plus second term, keep the numerator same value, minus 0.5 plus j 0.288, that is the numerator value. That is ck, that is we can say this is c1 and this is c2 and this is c3, the same values we can keep it. Divided by 1 minus e power, p2 we need to substitute. So p2 here minus 0.5 minus j 0.866. That's why I am substituting here e power minus 0.5 into e power minus j 0.86 into z power minus 1. So here e power minus j theta, we need to expand it. So e power minus j theta will be equal to cos theta minus j sin theta. E power minus 5 directly we can get it from a calculator. Similarly, substitute for the next value, minus 0.5 minus j 0.288 divided by 1 minus e power. So this value is minus 0.5 plus j 0.866. So e power minus 5 into e power j 0.866 into z power minus 1. So this is e power j theta formula. So cos theta plus j sin theta formula, we need to expand it. E power minus 0.5 directly we can get it from a calculator. Once if you substitute it and simplify, you get the answer as 1 divided by 1 minus 0.368 into z power minus 1. I am not going to substitute it. I am keeping this as separate expression. And this I am combining these two. So we need to take a numerator, that is denominator should be normalized equal, then only we can add a numerator. So I am taking a new denominator common and cross multiplying it and simplifying this. So once simplify, I get this minus 1 plus 0.66 into z power minus 1 whole divided by 1 minus 0.786 into z power minus 1 plus 0.368 into z power minus 2. That's the final answer. Thank you.